Hi everyone, it's Civil Engineering Tutorials. In this video, I'll show you how to draw half section and elevation of slab culvert in AutoCAD. To watch all the videos on this channel, click on the subscribe button and hit the bell icon to get regular updates from Civil Engineering Tutorials. Also like this video in case you find it helpful. So let's get started. So this is the half sectional plan which I have already created and its link is given in the description box. So now I'll create half section and elevation of this slab culvert. So this is clear span 1.5 meter. Here to here this distance is 1.5 meter and this is clear span. This is here to here 0.8 meter. This is width of BCC. And width of brickwork is 0.5 meter. This is width of brickwork 0.5 meter. Now this is 5.3 meter length of abutment wall. If we deduct 0.15 thickness of PCC from both sides, then this length will be 5 meter. So we have two numbers of abutment walls and this is wing wall. Wing wall length is 1.4 meter. We have four numbers of wing walls 1, 2, 3, 4 and this two numbers of abutment walls. This is parapet wall 0.4 meter and width of brickwork 0.5 meter. This is 4 meter roadway. This is also same parapet wall 0.4 meter and brickwork 0.5 meter. This is the section line. This is the roadway, 4 meter roadway. This is section line, section along A, B, C, D. So here section on AB, here we can see the front view because the AB section line is not going to the structure. So we can see the front elevation here and CD is going through the structure. So here we can see the sectional elevation. So that's why this is half section and elevation of slab culvert. So let's start our drawing. So first, check line command. I'll enter. Now specify first point here. This bilayer. Second point here. Now, here we have to take all the projections of these lines. So take XL. XL means construction lines. We need vertical lines. So first, click here. So click here. We need to take projection lines from this. Click here. Click here and click here. We can see section elevation from here. So here, thickness of PCC 0.3 meter. We need to take. So give offset distance 0.3 meter. Select this line and click on upward direction. So this is thickness of PCC. Now trim all the extra lines. Trim all the extra lines here. Trim here. Also trim here. Now trim, select, trim here all these extra lines and delete these lines. So now you can see here, I'll show you vertical line. You can see we have taken all the projection lines properly. This is when the vertical lines, so you can see we have marked all properly. Now here PCC level to ground level height, we need to take 0.3 meter. This is thickness of PCC 0.3 meter. Thickness of PCC is 0.3 meter. Now this is clear span 1.5 meter. This is the center line. So we need to extend the center line first. Draw a line here. Now extend, select this line and extend the center line. Delete this line. Now we need to mirror this to another side. Mirror. This is the mirror to another side. Now trim all the extra lines. Trim these lines. See, I am showing very slowly so that it will be easy to understand. Now take vertical line. This side also you can check. This side also same, because both sides are same. So this distance is 0.15 thickness of PCC. This is thickness of PCC. Now trim this line. Vertical line. Mark here on this point and on this point. This is clear span. Here to this line to this line. This is 1.5 meter. This is clear span. So we need to mark here also clear span. Here to here, this is clear span 1.5 meter. So now from this level to ground level height is 0.3 meter. So give offset distance 0.3 meter, 0.3 meter. Select this line and click. So this is ground level. Now extend this ground level to this side. Extend to this side. Okay. This is the ground level. Copy the text. This is ground level, GL. Go to properties. Make this 0.18. This is ground level. So PCC level to ground level height is 0.3 meter. So trim this Now we have to draw a line here. We have to provide stone pitching here. So, stone pitching width is 0.3 meter. Offset 0.3 meter. This is stone pitching. So, width of stone pitching also 0.3 meter. We need to hatch this. Hatch. Go to settings. Change the scale to 0.05 at pick point. Click here and click here. This is stone pitching. So width of stone pitching is 0.3 meter. We have to mark this. This is stone pitching. Reduce the height 0.10. This is stone pitching. Now break this. Break the center line. Delete this. This is stone pitching. Width of stone pitching is 0.3 meter. Now, slab height is 1.3 meter from ground level. Slab height from ground level. Slab height is 1.3 meter from ground level. So, give offset distance 1.3 meter. Select the ground level line and click on upward direction. This is slab. Now, extend this to another side. Select this line and extend. Now trim all the extra lines. Mark the clear span. This is 1.5 meter. Now trim all the extra lines. This is 0.3 meter. This is also 0.3 meter. So here we can see only 2 wing walls and we have 2 numbers of abutment walls. The 2 columns you can see, those are 2 abutment walls, and here we can see only 2 wing walls, but we have 4 numbers of wing walls. Here to here, this is 1.3 meter. This is slab height. This is a slab. So give offset distance 0.2. Select this line and click here. Click here also. Click to this side. Now trim all the extra lines. Trim this. Now delete these lines. So this is our slab. Also trim these two lines. Here. Trim this line and trim this line. So this is a slab. Here to here, this is 0.2 meter. 0.2 meter. This side also 0.2 meter. Here too, here also 0.2 meter. This is clear span. This is the slab. So now here we can see thickness of road, that is 0.22 meter or 22 centimeter. So here you can see, here the section line is cutting the road. So here we can see the thickness of road. So thickness of road is 22 centimeter or 0.22 meter. So we can see the thickness of road here. So give offset. And wearing course is 0.1 meter or 10 centimeter. We have to mention the wearing course, that is 10 centimeter. Give offset. Give offset distance 0.1 meter, that is wearing course. Now trim this. This is wearing course 0.1 meter or 10 centimeter. Now from here, thickness of road is 22 centimeter. So give offset again. Give offset distance 0.22 meter. Select this line and click to downward. Now here you can see, as the section line cutting the road, we can see the thickness of road here, and thickness of road is 22 centimeter. So trim this line, trim this line, delete this line. So this is thickness of road and this is 10 centimeter wearing course. So video became long because I have clearly and elaborately explained everything. Now hatch this. Scale 0.02. This is concrete hatch. So this is 10 centimeter wearing course and this is thickness of road 22 centimeter. Here to here, this is 0.22 or 22 centimeter. 0.22 meter or 22 centimeter. From here we can see the thickness of road. This is 0.1 meter. 10 centimeter wearing course. We have to mention here. This is Now here, give offset distance 0.22 meter. This is primary parapet wall. 0.22 or 22 centimeter thick primary parapet wall. Extend to this side. This is our primary parapet wall, 0.22 meter. This thickness of primary parapet wall is 0.22 meter or 22 centimeter. This is our primary parapet wall. This is 0.22 meter thick primary parapet wall. So now from here we need to give offset of 0.9 meter, that is coping. Coping height, give offset distance 0.9 meter from slab level. This is slab level. Click here. Now extend this line here to here. This is 0.9 meter. So extend this line. Now trim this line. Trim all the extra lines. Now this is our coping. Give offset of 0.1 meter, 10 centimeter, 0.1 thickness of coping. We have to mark projection of coping, that is 0.15 meter. Here projection of coping same as thickness of PCC. So extend, select this line or extend to both sides. Now trim all the extra lines. Now trim this line, also trim this line and this line. This is coping. Coping is 10 centimeter, 0.1 meter. Here projection of coping is 0.15 meter, same as thickness of PCC. This side also 0.15 meter. And this is our secondary parapet wall. This is our primary parapet wall and this is secondary parapet wall. This is coping 0.1 meter or 10 centimeter. This is, we need to mark 10 centimeter wiring course. Copy this text. This is 10 centimeter wiring course. We have to mention this 10 centimeter wiring course. This is concrete. 10 centimeter bearing course. This is concrete. Reduce the height 0.07. Now this side this side, you have to mark 22 centimeter thick road. 22 centimeter or 0.22 meter thick road. See, video became long because I have clearly and elaborately explained how to draw half section and elevation of slab culvert. And I am showing everything very slowly so that it will be easy to understand also. This is 22 centimeter thick road. This is 10 centimeter wearing course. You have to mention everything properly. This is 10 centimeter wearing course. Here to here 0.1 meter or 10 centimeter. Here 0.22 meter or 22 centimeter thick road. Here we can see the thickness of road. As this is sectional elevation and section line going through the cutting the road, so we can see the thickness of road. This is our primary parapet wall. This is 0.22 meter thick and this is our secondary parapet wall. This is coping 0.1 meter. Now this is the slab. Here to here this distance is 0.9 meter. Now we have to provide bars here on slab. We have to provide all bars here. So give offset distance. Here 5 centimeter or 0.05 meter. Select. Click to this side. Select. Click to this side. Also select. Click to this side. This is 5 centimeter 0.05 meter. Now trim this line. This is our main bar. This is our main bar. This is the main bar. So its dimension is 60 centimeter dia at the rate 10 centimeter spacing center to center. Diameter of this main bar is 16 centimeter and spacing is 10 centimeter center to center. Spacing means one dia to one bar to another bar distance is 10 centimeter. So I have mentioned here. This is the specification. This is my main bar 16 millimeter dia at the rate 10 centimeter center to center. This is main bar. So this is the main bar. We have to mark here. Copy this. This is main bar. This is main bar 16 millimeter dia and spacing 10 centimeter center to center. Now here we have to provide distribution bars also. So distribution bar 10 millimeter dia and spacing 22 centimeter center to center. Spacing means one dia to another dia distance, and another distribution bar dimension is 10 millimeter dia at the rate 18 centimeter center to center. I'll show you where to provide 22 centimeter spacing, we have to provide 18 centimeter spacing. Bent up bar 10 mm dia, 22 centimeter center to center, and hook is 9D. D is diameter of bar. So first we have to provide distribution bars. So first 10 millimeter dia at the rate 22 center to center, 22 centimeter center to center. We have to provide 10 millimeter dia first. Distribution bar to take circle. Now give radius 0.1 meter, 10 millimeter 0.1 meter. This is diameter of bar. Now hatch this. Hatch this. Solid hatch. At pick point, click inside. Now change the layer to distribution bars. Move this to here. Place here. Place here. Okay. Now radius you can check here. 0.01 meter or 10 millimeter. So now we have to provide all other bars with spacing 0.22 meter or 22 centimeter. So select this bar, copy, specify base point here. Now center to center distance 0.22 meter, 22 centimeter 0.22 meter, 0.22 meter or 22 centimeter. So here we are doing everything in meter. So 0.22 meter, specify 0.22 meter. Now 0.22 meter plus again here to second bar to third bar distance, again 0.22 meter. So we have to provide 0.44 meter. 0.44 meter. Enter. Now again add 0.22. So we have to provide 0.66 meter here. Next 0.88 meter. Now 1.1 meter. Now plus 0.22, that is 1.32 meter. Again add 0.22, that is 1.54 meter. 1.54 meter. Again add 0.22, that is 1.76 meter. And last, this is 1.98 meter. 1.98 meter. Enter. So we have provided all the distribution bars. Here you can see. You can check the spacing here to here. This is 0.22 meter. You can see here. You can check spacing of each bars. One bar to another bar distance. Means this is the spacing 0.22 meter. This bar to this bar distance 0.22 meter. Here to here. This is 0.22 meter. Ten millimeter dia at the rate 22 centimeter center to center. Radius is 0.01 meter, that is 10 millimeter, and spacing is 0.22 meter or 22 centimeter. 10 millimeter dia at the rate 22 centimeter, spacing center to center. So we have to mark this. You have to mark all the dimensions properly. It's very important. You have to mark all the dimensions. Now here too, this is also distribution bar. So dimension you have to mark here. If you want to change the text size, you can change, or you can keep like this also. You can change according to your requirement. See, I am showing very slowly so that it will be easy to understand. This is main bar, and we have provided main bar also distribution bars. You can change text height. If you want, you can change. Now, this side also you need to give offset. Give offset distance 0.05 meter. Select this line, click to this side and trim all the extra lines. Trim here, trim here, trim here and trim here. Now mirror the first distribution bar to this side. This is 1.5 meter. Mark here. Now mirror this. Give offset 0.37 first to this side, also offset to this side. Now what is this 0.37? 0.37 is L by 4. L by 4 means L is, I'll show you here. L is clear span 1.5 meter. L by 4 distance. This is here to here. This distance is L by 4. This side also L by 4. This distance is L by 4. L means clear span 1.5 meter. 1.5 meter divided by 4. So 1.5 meter divided by 4, that is 0.37 meter. So this is 0.37, this side 0.37. So this distance always should be L by 4. You have to mention this. L is 1.5 meter. This is clear span. L means clear span. This distance always clear span divided by 4. Now trim this line. Okay. Now you have to take 45-degree angle line here. From here you have to take the bar with 45-degree angle. So take line, give 45-degree, enter. Now mirror this, mirror. So this angle should be 45-degree. This angle should be 45-degree. You can see here, this is 45-degree. It's very important. This angle always should be 45-degree. This is our bent up or cranked bar. This is bent up or cranked bar. this should be 45-degree angle. This is a bent up bar or cranked bar. So mirror to another side, mirror to this side. Now delete this line. So this is a cranked bar. Now mirror this bar to upper side. Mirror the distribution bar to upper side. Now here, upper side distribution bar is 10 mm dia and spacing is 18 cm. You can see here 10 mm dia at the rate 18 cm center to center distance. Here spacing is 18 cm. So here one bar to another bar spacing is 18 cm. So select, copy, spacing, this is the base point, spacing 0.18 meter. Enter. Again from here we have to provide 0.36 meter. 0.18 plus 0.18, 0.36 meter. Enter. So we have provided these two bars here. Now you can check the spacing here. Here to here, one bar to another bar spacing 0.18 meter. Now this side also, this bar to this bar also 0.18 meter. So we have provided this bar. Now I will mirror all these bars to another side. Mirror to this side. We have provided all the distribution bars, main bar or bent up bar. We have provided all the distribution bars, main bars and bent up bar or cranked bar. Now we need to provide hook here. Hook is 90. Hook is 90. I'll show you that. One side 90, another side 90, total 18D. For slab, hook is taken as 18D. But here we can see 9D. 90 means 4D plus 1D. Okay. 1D means 16. Total is 90. 4D plus 4D and 1D. Okay. 16 mm dia, D is 16 mm. Okay. So D equal to 16 mm dia. D is diameter of bar, 16 mm dia. So 4D means 4 into 16, that is 64 mm or 0.06 meter. 64 mm or 0.06 meter. 4D is 0.06 meter. So hook we need to take one side 4D, another side 4D plus 1D. 1D means diameter of bar and 4D 4 into diameter of bar. One side 4D, another side 4D and 1D. Total 9D. 4D, 1D. Okay. This is hook. So here give offset distance 0.06 meter to this side. This is 4D. Okay. This length 4D. This length 4D. Both side 4D. Trim this. Trim this. This is 0.06. This is 4D. This is 1D. Dia part, this is this side 1D. So we have to fillet here for 1D. To provide 1D, D is diameter of bar, that is 16 millimeter. So fillet radius, specify radius 0.01 meter. Select this line and click here. So this is the hook we have provided. Trim this line now and delete this line. So this is the hook. Hook is 9D. One side 9D, another side 9D. Total 18D for slab. Here we can see 9D, so we need to mirror to another side also. We have provided this hook. Now we have to mirror to this side. Mirror to this side. So copy, select the hook. Hope you understand how to provide this hook. Now mirror to this side. Now trim, delete this line. So this is the hook we have provided. You can check here, this is 0.06, this is 4D. This side also 4D. And this is 1D, 0.01. Total 9D for one side. Total 9D. So we have provided hook also. So we have provided main bar, we have provided distribution bars, bent up bar or cranked bar and hook. All we have provided. This is bent up or cranked bar. This is a bent up bar or cranked bar. This is a bent up or cranked bar. You have to mention everything very clearly. This is a bent up. This is a bent up bar or cranked bar. Move this slightly so that it will be visible. Alright. Now this is bent up or cranked bar. This is 0.9 meter. This spacing 0.18 meter. This is spacing. This side also 0.18. This part to this one 0.18 meter. This side also same, here to here 0.18 meter spacing. This is also 0.18 meter spacing. So here we have to mention this part dimension. $18 millimeter dia at the rate 10 millimeter dia at the rate 18 centimeter center to center. This is 10 millimeter dia bar at the rate 18 centimeter center to center. Spacing is 18 centimeter. You have to mark all the dimensions properly and very clearly. (18 mm dia bar at the rate 10 mm dia bar at the rate 18 centimeter center to center. Spacing is 18 centimeter. Now this is coping 10 centimeter. This is 10 centimeter coping or 0.1 meter. You have to mark this. This is 10 centimeter coping. Coping is 10 centimeter. 0.1 meter 10 centimeter coping. 10 centimeter coping. This is abutment wall. We have two numbers of abutment walls here, and this is wing wall. Two numbers of wing walls we can see here. Draw a line here. We have four numbers of wing walls, but here we can see only two numbers of wing walls. Now extend this road. The road is continuing here. So here I'll mark the continue. Mark here. Here I'll mark the continuity mark here. Road is continuing here. This is I'm doing on free hand. This is road continuity mark. This I'll do with free hand. This road continuity mark. Road is continuing here. So we have marked this. So this is abutment wall, two numbers of abutment walls. Delete this line. Change the layer to text layer. Change all layers to text layer. turn off the text layer. I'll hatch this. Go to settings. Select this. Scale 1. At pick point, click inside. Now turn on the text layer. Now here, this is BCC. We need to mark. This is BCC. Copy to this side. Turn off the text layer, hatch BCC. I'll do mass properties. This is concrete. This is BCC. So turn on text layer now. Point 03 scale. So here, this side, except this side of abutment wall, this is abutment wall, except this side of abutment wall, we can't see all this. Except this side of abutment wall, we can't see all this. So we need to make all these lines dotted. So I'll make all these lines dotted lines. So I'll do mass properties. Change the line type to 0.01. Now mark all dotted. I'll make this dotted line as we can't see all this. Dotted line means we can't see all this. We have to break this. Delete this, break this, trim this line. So extend this. This is clear span. We have to mark. Now this line also we can't see. So do mass properties. This line also we can't see. So this is also dotted line. Only this line we can see. Now break this line here to here. This is the dimension line. Now extend this line. Now make this line also dotted line, as we can't see this line also. We can see. So mark here to here. This is 0.9 meter. So this is wing wall, this is BCC, this is wing wall. Now we have to mark earth slope, that is 45 degree. Take line from this point. So angle 45 degree, not 54. Angle should be 45 degree. Take line. .45 degree. So this is slope. So you need to mirror this to another side. In order to mark on both sides, we can mark on this side only. Mirror. This side we can't see. This side, as this is section, we can see only this side, as this is elevation. So trim this. We can see the slope on this side. Now from this point to here, from this point to upper side, we can see. So from this side to upper side, we can see this wall. So I'll match properties. This we can see this line or this wall. So above this slope, we can see this wall or this line we can see. So this is here to here. This is 45 degree or slope. This should be 45 degree or more, but not less than 45 degree. And this angle should always, you have to mark this angle should be 45 degree. This is bent up bar, cranked bar. This side also you can check. This side also 45 degree. So this is here to here. This distance is 1.25 meter and this distance here to here 0.8 meter. So this is the half section, half elevation. This is the half section and elevation on ABCD. Section LM ABCD. So we have to mark that ABCD. This is section line ABCD. So this is half section and elevation on ABCD. So hope you like this video. And if you like this video, then don't forget to like and subscribe the channel. Thank you for watching.